Good day, grade 12s. In this video, we'll be taking a look at some of the probability for grade 12, and we will specifically be going through the the question 4 from your term test, and then the question 10 from your June 2022 exam paper. Now remember, when it comes to the probability, we know that to calculate the probability, we take the number of times an event occurs over the amount of events that or possibilities, so the sample space, and by the counting principle, if we want to know the total probability, we just multiply the different outcomes to get the total amount of outcomes. Now, when we start to take a look at this, then we can then complete some of our questions. And you tend to be able to score a few easy marks there. Now, for the first question, this is now from the term test that you guys wrote. It gave you the following information. It tells you that Conrad investigated the effects of using a car phone on the speed that a person drives. He interviewed 750 people in his area, and the results of his survey are shown in the contingency table below. Now 4.1, the first question asks you to complete the contingency table, meaning fill in all the blanks. Now we know that in a contingency table, all your totals from left to right should add up into your total column, and then all your values from top to bottom should add up for your totals column. So in that case, we know that if we want to know how many people had no speeding violations that use the car phone, it would be 250 minus 25, which gives me 225. If I want to know the total amount of people that did not use a car phone, I take the 750 and I minus it by 250, which gives me 500. Then 500 minus 450 will then tell me how many people had a speeding violation and did not use a car phone. And now I can add up the 25 and the 50 for a total of 75 people that had speeding violations, and then the 225 plus the 450 for the amount of people who did not have speeding violations. Now, the next questions then asked you to calculate the individual possibilities of something happening. So you need to take how many times that event occurred and divide it by the total number of outcomes. Now, if we have the first question then asks you, okay, what is the possibility of a person having no speeding violation? So you go to your contingency table and you would say, okay, but there were 75 people who did not have, sorry. A person that has no speeding violations, there would be 675 people who in total did not have speeding violations out of the 750, and that would then give you a probability of 0.9, which is about a 90% chance of picking somebody that had no speeding violation. Question 4.2.2 then asks you, okay, what is the possibility of a person being a car phone user or a person who had no speeding violation? So meaning you can either pick somebody that had used the car phone or pick a person that had no speeding violation. So in total, that would then be it would be 250 over 750. Now there was 250 people who used their car phone plus 450 over 750 for the people who did not use their car phone and had no speeding violation. In this case, then that would give us a total possibility of 0.93. So about a 93% chance of picking a person who used the car phone or that had no speeding violation. Then 4.2.3, what is the probability of a person using a car phone and have a speeding violation? So in this case, you have to take a look at who you have to pick somebody that used the car phone and has a speeding violation. So both must occur simultaneously. And that was 25 people out of the 750, which would give me 0.03. Now, the last question then that you had for this is you needed to prove that according to this survey, being a car phone user and getting a speeding violation are independent events. Now we show this by showing that the possibility of event A and event B happening is equal to the possibility of just event A happening multiplied by the possibility of just event B happening. So in a sense, if we can show that this is true, we know that the events are independent. Now from the previous question, we already know the possibility of being a car phone user and having a speeding violation would just be 0.03. So now we need to show that the possibility of being a car phone user multiplied by the probability of having a speeding violation is also equal to 0.3. So in total, there was 250 people who used the car phone out of the 750, and there were 75 people out of the 750 people who had a speeding violation. If we then multiply these two, we get 0.03. Therefore, the possibility of being a car phone user and having a speeding violation is equal to the possibility of just picking a car phone user times the possibility of having a speeding violation, which is then indicates that thus the events are independent. Now remember, when events are independent, they don't influence each other. So this would mean that using a car phone did not influence whether or not a person got a speeding violation. If it was dependent, then using a car phone would influence whether or not you got a speeding violation. Now, for your questions from the June 2022 exam paper, I'm going to start off with question 10.2, because in this case they are playing around a little bit more with the values. So they tell you the two learners are selected at random from a group of 10 boys and 12 girls. That means there are 22 people in total. Okay, now determine the possibility that both are girls, and then for 10.2.2, one is a boy and one is a girl. So to assist us with this, I would suggest starting by drawing a tree diagram. Now we know that when we first pick, we can either pick a boy or a girl, and if we pick the boy, then our second option can either be a boy or a girl, and if we pick the girl first, our second option can either be a boy or a girl. Now remember, if you already pick one person, that person is not coming back in, okay, or there isn't a person that's the same as that person in the room, so these events would influence each other. So the first time I tried to pick a boy, I would have a 10 out of 22 chance of picking a boy. If I then try to pick another boy, I will only have a 9 out of 21 chance, because I already sent one of the boys away, and now there's one less person, which is one less boy. To pick a girl, I would then have a 12 out of 21 chance of picking a girl. Now, if we revert back and then just take a look at what's the probability of picking a girl first, that would be 12 out of 22. And if I then try to pick a boy after I picked a girl first, I would have a 10 out of 21 chance. Now, if I were to try to pick a girl after I already picked a girl, I would have a 11 out of 21 chance. Now, since these events follow on each other, like in 20.2.1, they ask you, what is the probability of picking a girl and then a girl? We know that we are going to have to multiply these outcomes to get the possibility. So the possibility of picking a girl and a girl is equal to the 12 over 22 times 11 over 21, would then give me a 2 out of 7 chance, which is approximately 0.29 as a possibility. Question 10.2.2 then asks you, okay, what is the chance of picking one boy and one girl? They don't care about the order, so you just need to have picked one boy or a girl. So pick a boy and a girl. Now there are two pathways that we can follow, but remember, each one of these branches happen individually, so we're going to have to calculate the possibility of one branch happening and the possibility of another branch happening and just add them together. So the possibility of picking a boy and a girl would be equal to the possibility of picking a boy then girl plus the possibility of picking a girl then a boy. Now the possibility of picking a boy then a girl would be 10 over 22 times 12 over 21, and then plus the possibility of picking a girl first, which would be 12 over 22, times the possibility of picking a boy second, would be 10 over 21. And this would then give you a 40 over 70, or 40 out of 77 chance, which would give you about 0.52, meaning you have about a 52% chance. Then the next question tells you, okay, in the Venn diagram below, M and N are independent events, meaning they didn't influence each other. And now calculate, giving correct to two decimal places, the value of X. Now in this case, they've summarized the probabilities in the table already for you. So we know that if we add everything together, it should be equal to 1. Now the fact that they tell you that that these events are independent, it means the probability of picking M and N should be equal to the probability of just picking M multiplied by the probability of just picking N. So if we were to try and determine this, then we could say, okay, so then we can say, okay, so the probability of picking M or N would just be 0.12. Then the probability of picking M would be the 0.12 plus this X, and then times the probability of picking the chance that N occurs, which would be the 0.12 plus the 0.45, which would give me 0.57. And now I can simply just solve for X. So I can start by multiplying in the 0.57 on both sides, or into the bracket. So then the 0.12 times 0.57 gives me 0.0684 plus 0.57x. I can solve for x, so I start by throwing over. So then I have 0.12 minus 0.0684 equals to 0.57x, which gives me 0.57. No, not 0. It gives me 0.0516 equals to 0.57x. Divide on both sides with the 0.57, and we get that x equals to 0.09. So just as a reiteration, we know that because these events are independent, we know that the probability of picking m and n should be equal to the probability of just picking m times the probability of just picking n. So then we can use this equation to solve for x. Now remember, I need to add the 0.12 and the x when I look at the probability of getting m, because remember, this x value is included in the event of m, and the 0.12 is included in the event of n. Okay, but that was that thing. 9, we know that for 10.3.2, that if we add the x plus the 0.12 plus the 0.45 plus the y, it should equal to 1, because your probability cannot be higher than 1. We substitute in all the values that we have, and y will be the only variable. We solve for y by throwing everything over to one side. So y is equal to minus 0.09 minus 0.12 minus 0.45, which is then approximately equal to 0.34. Okay, ladies and gents, and then with that, it is probability. Now, remember that I always say that when you take a look at a daunting task, you always start by, or I like to refer to an elephant. You don't eat an elephant all at once, you do it one by one. And just so the honeybee does everything one drop at a time, one little piece at a time.